Shampoo, paint, toothpaste, and ketchup. What do these substances all have in common? They're all very viscous liquids. But just how viscous are they? No one knows for sure, which is exactly what constitutes a non-Newtonian fluid. Viscosity is a measure of a fluid's resistance to flow. Take water, for example. It is an example of a fluid with low viscosity. It moves easily and freely as long as it remains in a liquid state. Syrup, on the other hand, would be an example of the opposite. It resists movement and flows much more slowly than water does. Its viscosity is high. Fluids that apply to Newton's principles concerning viscosity are known as Newtonian fluids. Essentially, he created an equation that describes the movement of fluids based on their stress and rate. This idea has later evolved into what we now know as the coefficient of viscosity. It is a constant that tells us exactly the degree to which a fluid resists flow. This constant will never change as long as temperature and pressure remain constant. However, some fluids can't be measured with this coefficient. For example, ketchup. It seems generally thick and more solid whenever it is sitting in the bottle. But after a quick shake, we all know that it comes out much more smoothly and easily. Some substances such as these can change so drastically after a force is applied that their state of matter seems to shift completely. These are known as non-Newtonian fluids. But how can non-Newtonian fluids behave this way? How is it possible for them to solidify and liquefy right before your eyes? Scientists have some idea of how they behave on the molecular level, but colloids seem to be responsible. A colloid is a mixture of microscopic insoluble particles mixed within another solution. Milk is actually a good example. While it seems like any other liquid, it is actually made up of microscopic butter and fat particles within a water-based solution. However, colloids come into play a little differently within non-Newtonian fluids. Let's take a look. Experimentation suggests that first, the applied force must move the liquid out from between the colloid particles. After the liquid is gone, colloid particles have the opportunity to interact with each other, which can generate friction. This friction causes the particles to lock up and instantly make the once liquid non-Newtonian fluid more solid. All in all, pressure makes non-Newtonian fluids more solid, and releasing that pressure makes them liquid again. Non-Newtonian fluids are very cool, very fun substances that you can even make yourself. Oobleck, which is 1 part water to 2 parts cornstarch, is a non-Newtonian fluid that you can make in your own home, so you can observe its unique properties for yourself. But just in case you can't, let's watch it behave on the speaker. Before the volume is turned on, it seems to act as a solid, moving with almost a Play-Doh-like consistency. However, after the volume is turned on, it behaves as a liquid, even though it remains in one piece. I hope I helped you learn a little bit more about non-Newtonian fluids, and I hope you find them just as interesting as I do. Thanks for watching!